Okay, good morning everyone. In this lesson we will continue with the inheritance examples. Okay, so firstly I'd create the employee class like this one with the standard constructor definition, and so I have given two arguments like this one, and then I can print the employee constructor in here because we want to know which constructor is created or the code by the program in the order of the order of the derivation. Okay, and so the self address must be passed into the this term, and another term is that this employee can be given with the self keywords. Okay, and so we can print the name and surname, which is given with these parameters, and so we should also give the address of this param. Okay, and so we can format of this string with the parameter of the self.name and self.address, and then this is the base constructor for for creating the employee or employee instance. Okay, and so we can drive the worker class in here like this one with the employee, and so if we write the def init function, and so the automatic name and address are defined in here with the with the super constructor parameters. Okay, and so we can add another property is the shift. Okay, and so we can print the worker constructor in here, and then we can give the worker with selves. Okay, and so the self shift can be assigned with the shift parameters. Okay, and also we can give the def disp worker with the self parameter, and can print the name, surname, addresses, and also we can give the shift. Okay, format self name, self address, and self shift must be given. Okay, this is the worker, but it's derived from the employee class, and so the name and address are contained within the worker parameters. Okay, and also we can drive another class. The manager is also employee for a company. Okay, and so def init should be given in here, but this super calls the employee constructor, not the worker, because the employee is a base class for the manager. Okay, and also we can get the print the manager constructor like this one. Okay, and also we should give the manager as a base class parameter with the self keywords, right? And so we can add another parameter like this one, the department. Okay, and this department must be passed into the into this constructor. Okay, so after that this manager should be called with the parameters of these terms, but we should give another term like this one, and so shift must be changed with the department, and also we can say the department. Okay, and also the class executive can be defined with the manager, And so the manager is derived from the employee, but the executive is derived from the manager. And so this executive both have the manager property and the employee property. Okay? And so if I call the def init function body in here like this one, and so the self, name, address, and department must be passed into this constructor. But also we can give another property in here like this one, or attribute as a region, and so the print executive constructor. Okay, and so after that the super function must be even with the executive and self parameters must be passed and then we can define the self region. Okay, and also we should give this manager function body like this one, and so this executive must be written on in terms of the region in here like this one, and so the self region must be given at this time. Okay, and so after that we can define the executive like this one with the name of the E, and Mehmet İşcan is my name and surname, and so YTU or YTU is the address of our parameter, and the department is the academic, and the region is, for example, Turkey. Okay, and so if I run this code, and then we will get the constructor definitions. Firstly, the executive constructor is called at this stage. Okay, because before the super call, and then we can write we have written to the print executive constructor, and after that this super calls this init function. Okay, but this init function prints to the print manager constructor like this one, but this manager constructor calls the employee class or employee constructor like this one. And so by using the one definition of these terms from the derivation rules or the inheritance, we will have the tree constructor calling mechanism in here. Okay, and also this executive can be called by these terms, and so every parameters are seen on the terminal page. Okay, is there any question about the derivation or the inheritance property in Python programming language? Could you see the mechanism for calling the constructor? Okay, and so we can change our example with some basic definitions. Firstly, I copy of whole of this code, but this code is changed with this function body. Okay, and so this is the same name, and the worker same name, manager same name, executive same name, and after that we can call this body in here like this one. Okay, so if I run this code and then we will have this function like this one, and so this is fine with the executive manager. But how about the other function? Because this executive is derived from the manager. Okay, and so every function manager should be transferred into the executive class or the properties or the methods. Okay, and so this executive possess this function, and so what about that? This is the override mechanism on the Python programming language. Actually, we have this function because at every definition this first defined, after that the manager this defined, and so this removed from these terms, And after that, if we have the executive with the function of the disp, and so this manager disp is also removed from the code. And this is an error, but this is not a syntax error, it's a runtime error. Okay. How can we overcome this problem? Firstly, we have the some mechanism in here, like this one, the super executive self-definition with the what? With the code disp. If we are using these terms, and then we will have the what? The super executive. What is the super executive? Super executive is called the manager class in here. Okay. So this disp can be called by using these terms. Okay. And so if I run this code, and then we will have these parameters. Firstly, we have the manager display function in here, and so this disp is not removed from the code, and so but we have also this disp function by using these terms. Okay. And this is another term of is the super manager, can be also written like this one, and so voila, this is the employee disp, this is the manager disp, this is the executive disp, and so this disp does not removed from the code in order to be utilized in the runtime application or this on this code. Okay, just remember that. Any question? Okay. So in the 7th example, we will talk about the object class. What is object class? Object class means that this is the parents for the whole classes in Python, which means that if there is a definition related to the some class, for example executive or the employee class, and so this class is derived from the what? The object class. Okay. For example, if we have the class sample in here like this one, but we can define this sample in the same analogy like this one. Okay. The Python interpreter automatically insert the what to sample with the what? With the object keywords. Okay. This is the class, and so the every class is derived from the what? The object notation, and so this two utilization is identical. Okay, with the upper definition. Just remember that. Okay. So how can we prove that this term? Firstly, we can expand our features, which is the MRO, method resolution order feature. In Python programming language, it returns to the hierarchical behavior of for a given class. For example, class A pass, class B A pass, class C B pass can be given, and so we can print the what? The C dot MRO. Okay. And so if I run this code, and then we will have the some tuple object elements with this definition. In order to show clearly in here like this one, firstly we have the class C, but this class C is derived from the what? The class main B, and this main B is derived from the class A. But at the end of this code, or the parents or the Adam or Eve can be called in the class notation is the what? The object class. Okay, and so we can easily set that this A is actually derived from the object, but the interpreter hides this information from us. Okay, this is simple example of the derivation rule in Python programming language. Okay, so in the ninth example we can show another property, multiple inheritance. Okay, for example, if we have the class A and if we have the class B in here like this one, and so we can define the C with the parameters of these terms like this one, and so we can pass this information. But how about the feature of the C? Feature of the C contains the B and A one. Okay, and so we can use the C by using both the A methods or the attributes or B methods and attributes. Okay, which we call it the double inheritance, right? And so what about the method resolution order parameter? And so if I run this code, we will have this output like this one. For example, the class main C is given in the first place. This is the derived class. Okay, and so the main A is the base class and main B is the base class for the C, and the class object is given in here like this one. But if I change this code with the B, and so we will have the class main B and class object is only seen on the terminal page, right? And so this hierarchical order can be given or can be obtainable with with this method resolution order function. Okay, just remember that. So in the multiple inheritance we will have, or we have, some mechanisms for the methods or any other terms it's given in the inheritance like this one. We can define the class A with the function of the foo, and we can define the def bar with the bar function. Okay, and so we can derive the C from A and B, and def tar self can also be seen on the page. Okay, so we can define the C variable with the C constructor in here. And so if we use the resolution operator or the dot operator or reaching operator by using with the parameters of the C, and so we can see that the foo, bar and tar are included in the options. Okay, and so each of them can be called with with this function. And so you can see that if we have the multiple inheritance, we can define or utilize the function which are given in the class A or B. But we cannot define or we cannot use the A function within the definition of the class B. For example, if we define the B like this one, and so B dot only contains the bar function, nothing else, because it's not derived from the A and it's not derived from the C. Okay, just remember that. Any question? Okay. For the multiple inheritance, we can define the def init function body like this one, and so we can print the a dot init code with the parameters of these terms like this one. And so we can give the type of the self in here in order to find out the which class is called in this notation. And after that, the self x can be created with the initialization values of the 10. Okay. And also we can give the def disp a function like this one, and so we can print the a disp function with the parameters of the format self x. Okay. After that, we can drive the b class from the a, and so def init can be given by using these terms. But how about these terms? We can print the b dot init called information is given in here like this one, and so the format type and self should be given. Okay. And so this super b, which is the given in the b, and so we can pass the self body in here like this one. But what about the definition of the self x 20? This tricky question, because we have the self x in the class a, and so if we can drive the class from the a, which is called the b, and so this b also kept to the values of the self.x, we can reach the x. But how come, or the what about the if we define the new variable with the same name within the base class? For example, this x is contained in here, this x is contained in here in the a, and so this problematic problem or not? We should search or debate about this topic in here. The print bdisp function body, and so we can format the self dot x. Okay. And so firstly we can define the b constructor in here like this one, and so firstly b init code in here like this one with the type of the main b, and after that we can call, or we must call the a init code, because this super is called in here like this one, and so this also, or this must be created in order to in order to drive the whole the properties to the other terms. Okay. And so what about the this b function? And so what's the values of the x in here? For example, if I run this code and then the bdisp is seen on the on the 20. Okay. Because we take this self parameter in here with the constructor definition, and so this x is updated in here even if it is defined in here like this one. But if I choose the disp a function body in here like this one, and so if I run this code, and so this is also called with the 20 values. Okay. But if I call this function in here, and so we will have the 20, because the b constructor must be called in here like this one. Okay. The self x is always updated with the with these terms, because at the end of this code this self x is updated before the before the super b self x. Okay. What about this definition? And so if I run this code, and voila, a disp and b disp is seen on the on the 10 values. Oh. And so the hierarchical formation or the order highly effective, or the highly affects to the to the r updated variable in here. And so this is the this is the basic rule to update or to obtain or to renew the values which is given in the class a and b. And so every variable should be called with the with the hierarchical order, and so you should notice that. Okay. Any question? If there is no question, we will continue with the multiple inheritance. Firstly, class A defined with the def foo with the self parameter and print a dot foo. Okay, and also we can define the class B with the parameters of the what these terms, and so def foo also given in the what in this notation, and so B foo can be called. And so what about the if I define the A variable with the constructor of the A, okay, and A foo is called in here like this one, and so if I run this code, the A foo is called because this A does not depend on any parameters B or object class, and so this foo is contained with what, with this function body, but this B calls the foo like this one, and so this foo is override with the what, with this definition, and so this foo is what written on the terminal page. But there is some names or the variable or the attributes that at the last class or the derived class change its parameters, even if it's the variable or the function, because in Python everything is interpreted as an address, okay, and so whatever the function definition or the variable definition are not takes into account to the what, to the interpreter, which means that if we have the in the last definition or the last line of this code we have this definition and there is no error, but this foo is removed this one, okay, just remember that. And also we need to give the another property like this one, a dot a foo, and so this a is called in here, and so this B does not affect, does not have any possession on the what, on this A parameter, because the definition of these terms is directly related to only the A constructor, not the B. B is derived from the A, okay? Just remember that. And so if there is any question, please ask me, because it's a highly complex mechanism in Python programming language, okay? Okay, so the class A, the foo can be given in here like this one, the a dot foo, okay? So another inheritance property can be given with the what, the def foo self, right? And also we can print the b dot foo, okay? So we can define the b, the type of the B, and so a foo B can be given like this one. So what about the output of this code? If we can call it with the a static class parameter in here like this one with the foo function, but the parameters which is given the b, and so if I run this code and then the a foo is called in here, and so this foo is not removed in here, and so the self of A can be passed with the child class to the child class, which means that this A foo, or if this A foo is called with what, with the derived class parameters or child class parameters, and then we can reach the base class foo even if this B override this function body, okay? But super function, built-in function, can be called with the class name and what, the self keyword, and so if we call this parameter and then this a foo is what is calling. Why? Can you answer this question? Because this super B and B is directly represents to the what, A class, because this super is indicated, or this super function indicates to the what, to the base class of our application, okay? But B foo can be called in here like this one, and so finally we have the b foo function like this one. Okay, any question? Okay, if there's no question, we will pass the another subject topic of the Python programming language, which is called with the overload and override concept. Okay, overload and override concept. This lesson I will show I've given some specific examples in the multiple inheritance parameters, and so we have some examples about the override and overload mechanism in the multiple inheritance with the application 2. Okay, but what's the meaning of these terms? In Python there is no overload mechanism, since we can define any function or any variable at the down side of the code, which means that we can define the a is equal to the 5, and after that, at the end of this line, we can change this a definition with what a is equal to the string Mehmet, for example. And so new variable and the function can easily be assigned to the another one in runtime application. And so there is no need for the overload mechanism, because if we have the two functions with the same name, and so one function is overload or one function is removed to the another one. Okay, and so this can be said that also the function or variable names or the class name can be changed by the program. Okay, for example, x1, the print foo can be given. Okay, so the print foo can be written, and also we can give the type of the foo like this one. Okay, and so if I run this code, and then this foo function is an address of the the 0 0 0 blah blah blah d0. Okay, this is the address of the function foo, and so this function is derived from the class function or possessed with the class function body. But if I call the foo function in here, and so this foo is written, but I can give the new definition of the foo by using these terms like this one. Other foo can be defined in here, and so we can derive this foo like this one. Also this foo is assigned with the with the parameters of the b, and then if I run this code, and so this is the variable, integer variable, this is the other foo, and this is the base foo. Okay, and so this is this is the overload mechanism or the override mechanism in Python programming language. But we cannot call this is the override or overload, because there is no overload mechanism in Python programming language, because in C or C++ programming language we have the overload mechanism with the same name of the function, but the arguments are always changed with another one. This must be satisfied in C or C++ programming language or C# programming language, but in Python every concepts are assigned to a specific address, and so this specific address can be changed in real-time or runtime application by using what? Adding the some codes like this one. Okay? Any question? Okay. Like this code 1, 2, 3 can be printed x, and x can be assigned with the Ali, and so we can print the x like this one. Okay, and also we can define another foo in here like this one, foo, and also we can define the new variable bar equal foo, and so we can assign the what, or we can use the what, the bar function body, in order to reach the information of the what of the bar definition. This is a simple example of the what override mechanism in Python programming language. Okay, so if this is the case, we can define the sum for each function with the parameters of L and F, and so for x in L we can call the fx in here, and after that we can print the what, the empty space, and so the foo x can be written with the parameters of like this one, and so this foo is assigned with the what, the format of x, and can be given like this one, and so the for each can be called with the what specific list parameters like this one, 1, 2, 3, 4, 5, and so this is the list, and so this x is assigned to the what, the list elements in here. But what about the f? F can be passed with the what, with the function name of these terms, and so if I call this foo function in here like this one, and so if I run this code, we will have the foo1, foo2, foo3, foo4, and foo5. Okay, but we can use this form like this one, the print. Okay, this is the same analogy for the what, for this utilization of the specific function body, or the lambda expression can be created by using these forms. Okay, any question? Okay, what about the class definition for the in terms of the overload and override mechanism? For example, we can define the class sample in here with the function of the foo, and so we can print the non-parametric foo in here like this one, and that foo self a can be given in here, and so we can print the parameterized foo like this one. Okay, and so as sample can be created in here. Okay, and so if I run this code, there is no syntax error, because either this foo or another this foo is removed from this code. But as foo with these parameters called the parameterized foo, but as foo we call this as foo, and so voila, we have the type error in here. Sample foo missing one required positional arguments with the a, which means that this function cannot be overloaded. This function is removed, and this is the new function body within the what, within the sample class. Just remember that. Okay, any question? Okay, and so what about this example? The foo self and print foo can be called in here like this one. The def tar self can be assigned with what, the print bar value. Okay, and so the sample bar can easily be assigned to the tar. Okay, and so we create the new variable in here in terms of what, the tar function within these parameters, and after that we can create the sample function in here like this one, and as bar can be called in here. And so this foo and bar can be called by the program, because we can add this star in terms of the bar function body in the code examples. Okay, and so we cannot overload any function body, but we can add some new properties or new methods or the new function into the what? Into the sample class. Okay, or sample x can be assigned 100, and so we can call the sample x in here like this one, and so 100 is seen on the terminal page. But what about the sx? Sx as is created in here, but the sample x is added at the downside or the downside of this code. Okay, and so this x is written or not in this case. This is the question. But this x is created from the sample class, and so this s also possess the what? The definition or the variable of the x right now. Okay, any question? So there's no question, we will have the 15 minutes break, and after that we will continue with the inheritance and overload and override examples. Okay.